Let's talk a little bit about data protection within our object storage platform in particular. One of the things that's very unique about our platform is that you can pick the protection level of an object or file down to that individual object level. And you'll see on all other platforms that we compete against, you can only have sort of a defined area that is one format, or the whole thing can only be one format. So what we allow are stuff called replication. And what is replication? Replication is where you store your file, okay, as an object, and it makes copies of them. Say you want 3 replicas, as we would call them. 3 replicas means there's going to be 3 copies, and those 3 copies are going to be distributed around the cluster so that they're not on the same node. They're guaranteed not to be on the same node. And in fact, there's a way to divide the cluster in such a way logically that you can guarantee it's even in special areas, so you could actually segment your cluster on power racks and protect against certain kinds of failures and disaster to increase your nines in protection. So the idea of replication is copies of something, all of which are identical, so there is no original replica and copies of it, there are only replicas. In addition to replicas, we have erasure coding. Erasure coding takes a file, when it stores it, and it breaks it up very much like RAID does. So RAID would use a term called 5.2, and when it breaks it up into 5 data elements and 2 parity elements. And it takes these slices, which it actually treats as individual objects in our system, and it sends it out into the cluster to be stored by different nodes. So you get a very nice high availability characteristic because it's not just on one machine with one set of disks that can fail. We've now spread it out inside the whole cluster. And so you get a very nice high level nines, and you get your data protected. And if for some reason one node or disk should fail, it will just replace that one element. Unlike in RAID, which has to rebuild the whole disk, we only replace the missing data. So it happens faster and it's less data to replace. And that's what erasure coding is. So the next thing I'd like to talk about is this feature called Darchive. We have Swarm composed of a bunch of different nodes. You can actually configure them in 2 ways. You can actually configure them as an archive node where what they do is they have, say, a bunch of disks in them, and it will fill one disk quickly and then move on to the next and fill and the next and fill. And what Darchive does is Darchive will notice that a disk hasn't been accessed in a while, and it'll actually spin down the disk, and if in fact the whole archive node fills up, it'll start lowering the CPU utilization on the disk as well. So you'll end up spinning down all your disks and spinning down the actual CPU utilization. It'll stay up just a little bit to pay attention to what's going on, but it'll actually save you significant power savings. So as you build a cluster that is both active and archive material, we can start to turn it into Darchive material by having the archiving mechanism start spinning down your clusters. And the way this works within Swarm, say you've made 3 reps of a file. It will store those on a bunch of different nodes. And if it actually goes to access this file, it will only wake up the one node that can service it, and the other 2 stay asleep. So not only does it optimize your dark data, it will only wake up the necessary node to do that, and it'll first check to see if somebody's already awake who can service that request. And so Darchive provides you an opportunity to have up to 30% power savings on your cluster in an environment, and potentially more if you have a significant portion of your cluster that is basically Darchive or an archive that is infrequently accessed.